Hello, students. Let's get to work. This is 8th grade math, unit 4, lesson 9, activity 2. And the name of this activity is water tanks. Put that on the top of your paper. Water tanks. Okay, let's read the problem. The amount of water in 2 tanks was measured every 5 minutes. Simple enough. Here's a picture of the 2 tanks. Okay. The table shows the volume of water in each tank, measured in intervals of 5 minutes. Okay, let's take a look at the table there and make sure we can figure out this information here. Okay, time in minutes there, 0 minutes, 5 minutes, 10 minutes, 15. Okay, here's tank 1, the volume of water in liters. So at 5 minutes, it had 175 liters. At 0 minutes, like from the start, it already had 25 liters of water. Got it. Okay, in tank 2, from the start, at time equals 0 minutes, it has 1,000 liters of water. Okay, got it. After 5 minutes, it has 900 liters of water, and so on and so on. Okay, good. Question number 1. Look at the data in the table. Describe what is happening in each tank. Okay, I want you to pause the video, look at the data in the table, and then write in the box, type in what's happening in each tank. Go ahead and pause and do that now. Okay, did you finish writing in what's happening in each tank? Look again, take 1. As the time increases, the volume of water in the tank is also increasing. Somebody is filling the tank. And for tank 2, as time increases, going down the table, the volume of water in the tank is decreasing. Somebody is emptying the tank. Okay, type in your answer here. You can type it in using your favorite color, whatever that might be. My favorite color is purple. So I'll go up here and choose purple. Okay, so it looks to me that as time is increasing, the volume of water in tank 1 is increasing. It is filling up. I'm out of space. I'll just make my font a little smaller. I'll make it 10 so my teacher can't read it. This is going to be hilarious. Just kidding. Please don't do that. Let's see. What about tank number 2? The volume of water in tank 2 is decreasing, like someone pulled the plug and water is draining, maybe. Okay, I guess that's a little too small. My teacher's gonna really hate that. How about 12-point font? Whatever. Okay, let's go on to problem 2 after I fix my spelling. There we go. Problem 2. Just by looking at the table, estimate at what time both tanks will have the same amount of water. Okay, so just by looking at the table, can you see when both tanks have the same amount of water in them? At the very beginning, tank 1 has 25 liters, tank 2 has 1,000. That's really, really different. Very far off. How about 15 minutes? Tank 1 has 475. liters, and tank 2 has 700. Not the same. At 20 minutes, getting closer here, tank 1 has 625 liters and tank 2 has 600 liters. That's very close. Now, if time increases just a little more, then tank 2 loses volume and tank 1 gains volume. So it's not going to be more than 20 minutes. It's going to be less than 20 minutes. Almost 20 minutes, but not 20 minutes and not more than 20 minutes. I guess somewhere between these 2 points, the tanks had the same amount of water. Somewhere between 15 minutes and 20 minutes. And it looks to me like closer to 20 minutes. The tanks had the same amount of water. So let's go ahead and type our answer in. I'll use a pretty color. At around, no, not around, somewhere between. Let me do it that way because I'm not really sure. I didn't do any math. Between 15 and 20 minutes, both tanks will have, oops, I wrote right off the screen. Both tanks will have the same volume. Okay, go ahead and type yours in, pause the video and do that now. And I'll clear my screen and let's keep going. Next question. The amount of water in liters in tank 1 after T minutes, is 30 times T plus 25. The amount of water in liters in tank 2 after T minutes is, I'm going to just put a space there so it's easier to see it. Negative 20 times T plus 1,000. Find the time when the amount of water will be equal. How do we find the time when the amount of water will be equal? Okay, this is where we're going to need to start doing some math on paper. So you've got your notes ready, don't you? This is the problem water tanks. Okay, let's go ahead and write down the given information. Just write given info. And then for tank 1, we are told the volume, I'm going to write volume 1. The volume in tank 1 at some minutes called T equals 30 T plus 25. Okay, they give us that information. And they give us the information for tank 2. So for tank 2, the volume equals negative 20 times T plus 1,000. Now, if you were not very good in Unit 3, if you didn't feel comfortable making these kinds of equations, you'll need to go back and review Unit 3. But really quickly, I can describe it for you. Okay, so looking at tank 1 right here, it's saying that the volume, when time equals 0, at 0 minutes, the volume already has 25 liters of water in it. So it has like a y-intercept right here at 25 liters. And then every minute it is increasing by 30 liters. That's what this 30 here means. That's the rate that the volume is increasing. And I know it's increasing because it's positive. So every minute we get 30 liters more, like this. There, it's increasing at a constant rate, but it started from 25 liters in the tank. I can get that information just from this formula. So that's what Unit 3 taught us. There, okay? So this graph has time on the x-axis in minutes and volume of water on the y-axis. Now, what about this other equation here? Let's look at that one. So if the time equals 0 minutes, 0 minutes have passed, then the first term in this equation disappears because t equals 0. 0 times negative 20 cancels out, and we're left with just 1,000. So that's telling us that the volume started at 1,000 liters when time equals 0 at the beginning. And then every minute we lose 20 liters of volume. I know that it's losing 20 liters of volume because it's negative. So every minute that passes, 20 liters of water leaves the tank. It drains out or leaks out or whatever until we have no more water left in the tank. Okay, I know all of that just from what I learned in Unit 3. Okay, let's keep going though. Now, what can we do with these equations? Question number 3 says, right here, find the time when the amount of water in both tanks will be equal. The amount of water in both tanks will be equal. That means we want to find, and write this on your paper, we want to find when volume 1 equals volume 2. And we want to find that time. So here's what we can do. We're going to set the first equation equal to the second equation. Why are we doing that? Because we're saying that volume 1 equals volume 2. We don't know what volume that would be, but we can find the time by setting these equations equal to each other. Watch and see what that looks like. So we're going to say the volume of tank 1, which is 30T plus 25, and don't get confused with my T's and pluses. My T has a little tail and my pluses as straight as can be. The volume of tank 1 equals the volume of tank 2, negative 20T plus 1,000. Now, I don't know what that volume would be, but it's going to be equal. And now we can solve for T. When we solve for T, we can find at what time these volumes really would be equal. Okay, so let's go ahead and do that. Let's solve for T. And we've gotten pretty good at solving equations by now, but I'll give you a review. Remember that you want to get all of the T's on one side of the equation. And in order to do that, you can add, subtract, multiply, or divide to both sides of the equation. You must keep it balanced. Okay, so I've got this negative 20T over here. I'm going to add 20T to both sides of the equation to kind of move it over. I'm not really moving it over though. I'm going to cancel it out from the right side of the equation, and then it looks like it moves over to the left side. Anyway, 30T plus 20T equals 50T. And these T's here cancel out. So now I have 50T plus 25 equals 1,000. Now I still have not got the T all by itself. This T, 50T plus 25 is a problem. I'm going to subtract 25 from both sides of the equation. And I did that so this will cancel out. And I'm left with 50T equals 975. Make sure you're following along on your paper. Okay, finally, I still have not isolated the T because it's being multiplied by the number 50. I have to undo this multiplication using division. So I'll divide both sides by 50. When I do that, I get this 50 divided by 50, that equals 1. Always remember that any number divided by itself always equals 1. So I'm left with t equals 975 divided by 50. I'm pretty good at fractions, but if you're not, this is a great chance to review. Okay, so this is an improper fraction. We have, is that right? An improper fraction? Yeah, it's called an improper fraction because the numerator is larger than the denominator. You need to reduce the fraction and we'll get a mixed number. So how many times does 50 go into 975? 50 goes into 975. Let's think. 19 times with 25 remaining. Now 25 divided by 50 is the same as 1/2. So this answer is 19.5. And what this tells us, t equals 19.5 means the time when both tanks will have the same volume of water is at 19.5 minutes. Now you need to show your work on your screen. Let me help you do that. Because when you show me your work, I know you really did it. So choose your favorite color. I'm going to go with green this time, though. Now, remember what I said. The time when both volumes are equal is when volume of tank 1 equals volume of tank 2. So here is the equation for the volume of tank 1. And I'm saying that equals the volume of tank 2. And look at your notes. This is exactly what you wrote down with me. Now, how can you show the steps to solve this? Well, just write under each line what you've done. Hey, I thought I was writing in green. It didn't change to green at all. Oh well, I'll use green now to show the steps. Maybe that is green and I just can't tell. Anyway, the first thing I did was subtract. I added. The first thing I did was I added 20 to both sides. 20t, you might have used a different step first, but this is what I did first. I added 20t to both sides. And then I'm going to change my color back to black. I got 50t plus 25 on the left side is equal to 1,000. And then the next thing I did, I'm going to go back to green. The next thing I did after that was I subtracted 25 from both sides. And I got 50t equals 975. And we've already done this on paper, so it's not going to be too hard for you now, right? I'll make that a little smaller. No, that doesn't work. I want to start writing over here now. I'll just decrease this font size. There we go. Okay, now I divided both sides by 50. Here's how you can show that. Wait, let me make this larger again so you can see what I'm going to do. Okay, to show that you're dividing both sides, why don't you go ahead and put parentheses like this, and then using green so that I can see it's the next step, divide 50 on that side and use parentheses. It's kind of annoying to do it on a computer, isn't it? Oh well. Welcome to the future. There we go. Okay, I'm dividing each side by 50. And then I can give my final answer. I've simplified it on my paper. You don't need to show me the steps for simplification. That's really not the point of the problem. But you must make sure that you put your final answer. Oh, it's going to auto capitalize it for me. That's not really what I wanted. I want to keep it. There we go. T equals 19.5. This is important. Make sure you put minutes. I want to see the units of your answer because it better make sense. If you said 19.5 liters, I would be shocked. How can you get liters for time? Okay, good job, guys. Now, I would like to ask you some questions about this, though. I want you to think about the answers. What does T represent in the first equation and the second equation? I'll circle that for you. Here's the T. What does T represent in these equations? Think about your answer to that. Next question. After we substitute in a time for T and simplify one of the equations, what does the number represent? So if you substitute in a time for T right here and then solve the equation, what does your answer represent? Let me do that here in pink. Let's say we substitute in T equals 10 minutes. Then you'd have 30 times 10 plus 25. What does your answer represent? When you simplify that, you get 300 plus 25, 325. What does 325 mean? Remember, that's the volume of water, so that's in liters. The units of that answer is liters. Maybe I'm not very good at spelling that, though. Okay, next question I want to ask you is, how accurate was your estimate that we had on the previous slide? When we estimated at what time both tanks would have the same amount of volume, how accurate was your estimate? Well, I said between 15 and 20 minutes, and our answer is 19.5 minutes. So not bad, I was accurate. Okay, I have another question for you. If you had both of these equations, but nobody told you which tank goes with which equation, how could you figure it out? Remember the data table on the previous slide? One of the tank's volume was increasing, while the other tank's volume was decreasing. From these equations, how could you figure out which one is which? Well, look here, 30 times the time means every minute the volume's increasing by 30 liters. And in this equation, negative 20 multiplied by time means every minute the volume of water is decreasing 20 liters. So you can tell just from the equation that this tank is decreasing and this tank volume is increasing. Okay, let's stop there and I'll let you go to the next slide and answer those questions in your own words.